We're going to continue on with the tic-tac-toe game, but actually we're not going to do tic-tac-toe. What we're going to do is we're going to add chess. Not chess, checkers. I want to add some, we'll get to chess later. I want to add something simple that's very similar to tic-tac-toe. So they're similar in that they both only have one kind of piece, right? X or O, black or red. I don't know if I can cancel it. We copy a whole package. So I'm just going to make a new Java package. Call it checkers. So now this will be a checkers game. This will be checkers piece. And we'll also make a checkers player. So I have a couple of reasons for doing this. One is to show you generics, but the other is to show you why you want to start working in twos or threes. So the by making two things that are very similar but different, I can see if there's a way that I can further abstract things. So pieces, no real difference between the piece, right? It's a checkers piece, and it's got the get symbol. Well, so that's going to be different because actually we're going to use a piece color is black or red, right? And a checkers player. I'm just debating if I should use actual color or if I should use the yeah, let's use color. Or use a string to represent the color. So now the color here's a case where I actually don't have to use the dot equals. Color dot red. See, it's a static. It's final. That means it's a constant. When we're dealing with constants, we are allowed to do this. Because here we actually do want to compare the actual equality, because you can only be one occurrence of black. There can only be one occurrence of red. So what we want to check is for the reference equality. Is C actually the same value, literally the same value as black, literally the same value as red. To be consistent. So that works out well, except this doesn't take a string in player. So let's go take a look at player. So players have a name. Okay, cool. So I guess the name could be the red player and the name could be black player. Or is that really what I want to do? Do I want to have them with a name? Right? Is the color a good name? So actually, I'm going to go with the color is actually a good name. So, see, is it? It's probably not. So I will have to. I will have to decide if I want to use the color. How am I going to convert it to a string? So there is toString, but toString is not going to give me what I want. It's going to be some whacked out color code thing of, you know, the hex value of the colors or something. So that's probably not great. And I can't do if statements, so I guess the way I want to do this is pass in the string name, and we'll use the name. And that means I'm going to go back to the tic-tac-toe player and rip off this code again. And put this back as an actual string just to make it clearer for people in the message. But then I actually do still want to have that okay, so now we're going to change this if statement to be a little bit different for sanity's sake, so I don't have to repeat myself. So what I want to check is, if the name is black, I want to make the color is assigned color to black, else if it's red, at some point in time they had lowercase and then they changed to uppercase. You should use uppercase because it's good. Oh yeah, they added so if I use lowercase, that was added in JDK 1 or before probably, and the uppercase ones they decided constant should be uppercase, so somebody went through and fixed that, presumably. So if it's black, we're going to set it to a black color. If it's red, we're going to set it to the red color. Otherwise, we're going to throw the illegal argument exception. We didn't need to do that in the tic-tac-toe player because we're not doing any sort of additional assignment here. So the two players do work different. I should also be writing a unit test. For the interest of time right now, I'm not going to. So there's a checkers piece, and it's actually the same, but I don't actually want it to be the same because I actually want this to return a color. So in our checkers player, I also am going to want to add a get color method. One day I will configure all this, see if I can make it go to the bottom instead. Just haven't gotten around to it yet. If I do that, I will make a video. So this is cool. The only problem is that owner, if we go to it, no, multiple problems, but the big problem is if we go to owner, it's a player, not a checkers player, not a tic-tac-toe player. So this is a really good opportunity to use generics because this piece has a different kind of player depending on which kind of piece I make. So I'm actually going to make this a generic. All I do is these weird angle bracket things, and I put in T. T stands for type. I could put in X, I could put in K, V, value, type of player, right? Whatever I want to put in. Typically we just call it T. And then I'm going to say that this player is not a player, it's a T. Actually do want this T to make sure it's a player, so I need to say extends player. So now what I'm saying is that this piece belongs to a particular type of player. And now this has to become T as well. and this becomes T as well. And there we go, right? So what I've said is this piece has some kind of player. We don't know what kind of player. Here's the kind of player here. Here's the kind of player here. Here's the kind of player here. This all winds up being a tricky thing behind the scenes. Remember, the whole purpose of, not the whole purpose, a big purpose of object-oriented programming is to get rid of casting. Underneath the hood, this actually becomes an object, and this becomes a cast to the appropriate player type and all that kind of thing. But that's all taken care of by the compiler. From our point of view, there's no casting, there's no if statements, nothing like that. So there we go on that one. So now if we go back to the tic-tac-toe player, we're going to find out that, well, actually, let's fix this first. So get symbol returns a color for this one, and it returns a string for this one. So if we go back to piece, that means this, okay, go back to player. No, sorry, it is piece. So let's go to piece. There we go. Going the wrong thing. So this thing also needs to be generic, but it's not going to be T, because that would be saying it returns a player, which we don't want. We want this to either be a string or a color, or whatever else they choose to pass in. So this is going to be the S for symbol, is what I'm using it for. Right? So now when we create it, when we deal with a piece, we're going to have to say it belongs to this kind of player and it uses this kind of symbol. So now if we go to tic-tac-toe piece, you'll see it's unhappy here because we are passing it a piece without telling it what kind. So it belongs to a tic-tac-toe player and it returns a string. And the same will happen for the checker one. So this takes a checkers player and a color. Now this works, right? So we don't have to, or we're able to say that this method here, public color get symbol, and this method here, public string get symbol. Now remember, we can't override based on a return type. We can only override based, overload. We can't override based on a return type though, as long as they're compatible. So string and color aren't compatible. They're just both objects, which makes them compatible at some level. And if we look up here, we're overriding the method that says, I don't know what type this is, you tell me. And we tell it by passing in this generic here, and that generic here is a string, and the generic here is a color, and we're dealing with a color. So now I've written my code in a way that it works for the generic piece works for either a checkers game or a tic-tac-toe game. So let's just make sure there's nothing else weird going on here. Okay. So that's creating a generic class. Let's see about using it. So our tic-tac-toe game, let's think about a game in general. So how does a game work? So generally a game has, we'll fix this later. For now we're just going to say it has two players. Okay, you've got tic-tac-toe, you've got the X player, the Y player, you've got checkers, you've got the black player, the red player, chess, black player, white player. If you're dealing with Monopoly, you've got the different, like the dog and the thimble and the hat or whatever. So that will have more than one player, but we'll worry about that later on. So we could make an array of players. We'll ultimately change this to a collection of players. But this also isn't what we want, because this player is going to be the raw type thing that we just had, right? So we shouldn't make a player. We should make a player that belongs to a particular kind of piece, or to a particular kind of player. So this becomes T as well. Now, also, I'm gonna go back to sanity for just a brief second. I'm gonna go to the piece, and I'm gonna change this to P for player, just like I have S for symbol. Like I said, T is not a requirement at all. Use whatever makes sense to you. So then in our game, I'm gonna have the same thing. I'm gonna change this to P for player. If I choose to make my players final, that's fine. I have to set them up in the constructor. That means that I couldn't change a player partway through a game, or I couldn't reuse the same game for two players. So this is a design decision. Is my game, I create the game brand new each time I go to play a game, or do I create one game and just reset the pieces on it when I want to play the next game? That's a design decision. I don't have a good or bad answer for that. For now, I'll make it that we're going to reset everything. So remember, if you're dealing with an abstract class, generally you're going to make a protected constructor because it doesn't need to be public, right? The only thing that can call it is a subclass, and that's all we're calling. Protected, and when it's a subclass, it only needs to, the purpose is protected is something that's accessible from the subclass, and that's what we need here. So it's a game. Honestly, this really bothers me. I like to line them up. So again, we have to think about what could go wrong. So if player 1 equals null, students will do this. Or player, not just students, lots of people do this. Not player, this should be player A and player B. So, you're not seeing me clench my fists. So what am I going to throw here? It's either A or B, right? So maybe I'll make a generic message like players cannot be null. Okay, which player? Was it player A null or player B null? I don't know. So I don't like to combine those things. I want to give a specific message if I can. So player A cannot be null. And remember, I had that the idea of a checks class that I could use that would, we saw that in the exception one, where I could just say, check that this is not null, check that that's not null, and then these become one line each. But yeah, I'm not going to worry about it right now. Just set up my players. So that's cool. Now how do we play a game? So a game is basically done by getting a turn from each player. That becomes an interesting idea of having a turn object. If you just say, oh, I want to go to this, like if you measure a tic-tac-toe square, right? We've got, how can I draw one? Right, so we've got, yeah, that's really hard to visualize. Right, so there's a tic-tac-toe board, right? So if each of these is I want to go to row 0, column 0, row 1, column 1, row 0, column 1, row 0, column 2, and all that kind of stuff. I can just remember who took what turn and all that in a very complex thing. But if I actually make a turn object, I can remember that this piece went to this square. Think about Monopoly. It might say something different. It might say this person made this roll, right? They also picked up this card. They also did whatever, right? So there's turns could be a very powerful thing. I'm not going to worry about it just yet. I guess we could make the abstraction. Just so we have, I'll just make a turn. We'll fill this in another day, not right now. So if we go back to the game, a game is done by taking turns until it's won, right? So we could have a get winner method and just play the game until it's got a winner, but that can't happen, or that can happen obviously, but that there could be a tie in the case of tic-tac-toe. So maybe we'll just make this a Boolean is over, right? And if you're talking about the generic game, how do I know when a game is over? Right? Well, it's when it's tied or there's a winner, but I don't know how to, like, every game is a different way to win, right? Every game has a different way of declaring there's a tie. So the concept of how I do that is shunted down to the child class. That's why I made an abstract class game, because not all games are played the same. If we're talking about turn-based games, player 1 goes, then player 2 goes. Player 1 goes, player 2 goes. Player 1 goes, player 2 goes. Some games might have the concept of skipping a turn, though. So there's a number of things we need to consider. So that's another thing. Next player. Right? So if you've in a game that has it so you can skip turns, so you can't just say, well, we start with player 1 and then get player 2 and then go back to 1 and 2. If there's a skip, you go from 1 back to 1. So we want to get the current player. Right, so we're going to get the next player. And then we're going to turn. Oh, this should be P, not player. Turn. We're going to ask we say that the turn is assigned current player dot take turn. Now that doesn't work, obviously, because we do not have this concept of a take turn method inside player. So we have to go to player and make an abstract method for take turn. Why is it abstract? Because taking a turn in checkers, taking a turn in chess, taking a turn in Monopoly, taking a turn in tic-tac-toe, totally different, right? In Monopoly, you've got to roll dice. In tic-tac-toe, you pick a square. In checkers, you pick a piece and a square, right? So totally different. So we go back to game. And I've actually, there's a there's a new abstraction. If you think about this game, it's really a turn-based game because we're taking turns, right? One after another. It's a serial turn game. What about a game like Tag or a MMO like World of Warcraft or something? Everybody can do everything all at the same time. So the structure of this would be very different. So the game here that I'm creating is really a turn-based game. So I should really change this to turn-based game, but I'm not going to. We'll just say that this is the kind of game that we want to support. So what's it unhappy about here? Is assigned but never accessed. That's fine. We're not using it yet. So what happens after this is that we get the next player and they take their turn. Okay, so what we want to say is, well, not is over. Right, so the game isn't over. We're going to get the next player and we're going to have them take their turn. And then check to see if the game's over. If it's not over, we're going to get the next player and take their turn. And if the game is still not over, we're going to get the next player and take the next turn, right? So it could be player 1 goes, player 2 goes, player 1 goes, player 2 goes, player 1 goes, and the game is over because they won. They got tic-tac-toe, right? 3 in a row. So that could be how the game goes. Right? So that supports that. Think about this for chess, right? Well, you still have a king basically, or the game hasn't become a tie, which is possible in chess. Well, you still have a king. Take your turn. Well, the next player still has their king. Take their turn, right? And keep going until somebody no longer has their king, or we've gotten to a tie. Same with checkers, right? How many pieces do you have? Do you have more than one piece? Okay, you would continue the game, right? So this general concept here works perfectly for everyone. I could make this final. If I make this final, what I'm saying is no one can override the method, and this now becomes what we call a template method. So it's a template method because it forms a template. All games follow the same pattern. You can do that. It makes sense in certain cases. But in this case, I'm not that smart. I don't know if there's a game out there that's played radically different than this. So I would rather not make it final and let people override the play method if they need to. If they couldn't override the play method, now they can't use my whole game framework. So use that final very sparingly. Sometimes it makes perfect sense. Other times you're not necessarily so smart. So let's go to the tic-tac-toe game. And it's unhappy because we haven't overridden the method. So let's override the methods. So this will be a tic-tac-toe player. Just return true for now. And return null for now. Now, those are horrible things to do because it's not going to work for us. So what we want to do is we can throw a new illegal state exception. Quite often I make my own exception for not implemented yet. So not implemented yet exception. But we can do that just by throwing a legal state exception. So this is better because now it's going to crash when we call that method. Now it's like, oh, that's the next piece of the code I have to implement. So our checkers game will do the same thing. The problem is that board game won't work. Why won't board game work? Can you guess? Right? So I'll take a look at game. So first off, tic-tac-toe game to board game, that worked. Board game to game doesn't work. And game is here. So can you tell why it doesn't work? Pause the video. Take your guess. And now I'll show you, then unpause again. So in board game, if we put the mouse over here, we're going to see that, first off, there's no constructor. So let's do that. Right, because you're told you have to take 2 players. This is wrong, right? You can imagine a board game like Monopoly with more than 2 players, but for now we're just saying our game takes 2 players. You can also have 1 player. Imagine a game of solitaire with it's not a board game, but it's a card game, right? Solitaire is a single player game. Now it's unhappy about this. So if you guessed the other piece, it's because we didn't actually say what kind of game we're creating, right? We said the game requires that you pass it a player, right? So a board game also has no clue what kind of my mistake. A board game has no clue what kind of player it's going to be, right? Is it going to be a tic-tac-toe game, or is it going to be a checkers game? Those are the 2 games we have right now. So this will become checkers or tic-tac-toe. And obviously we're passing a player when we should be passing a P, right? Because I could be passing a Monopoly player to a tic-tac-toe game. It wouldn't make any sense, right? And that's what we're trying to avoid. We're trying to make it so that we can pass the specific type around, right? Whatever's in here, but we don't have to declare it here. Imagine if we had to declare every single kind of thing. We'd have to create a board game that took tic-tac-toe players, a board game that took chess players, a board game that took checkers players, a board game that took Monopoly players. Using this generic says we can create a board game that takes some kind of player. I don't know what kind of player it is. All I know is that it extends player. And then in the case of the player, or not player, piece, we have a piece belongs to a particular kind of player, and it also has a particular kind of symbol. I don't care what the symbol is. Symbol could be an object, it could be a database, it could be a color, it could be a string, it could be an integer. Doesn't matter to me. Here, this has to be a player. Okay, so board game is happy now. Tic-tac-toe game probably isn't happy anymore. Tic-tac-toe game's not happy because we didn't tell it that it takes a tic-tac-toe player. It's also unhappy because we didn't give it its constructor. Couple of ways we could do this. We could have the tic-tac-toe game require to take a couple of players, or because we know it's going to require an A and a B player, one with X, one with O, we could just say new tic-tac. And this is the one time I will call a method, a constructor, passing in a value that's created like this. Right, so I could hard code it, or I could have them pass it in, or I could say, well, I can support either. Right, so you can just create a tic-tac-toe game and it'll give you an X and an O, or I can create a tic-tac-toe game passing in my particular players. It would totally depend on what makes sense for you. Since I've typed this in, I'll just leave it there. So is the game over? Hard to say, right? That's a much harder, much more involved bit of code. We'll get there. Getting the next player, we can do that. That's simple, actually. We can say private tic-tac-toe player, current player. So the get next player is if the current player equals null, we'll call this next player. Yes, I know this is wrong. And I do want to use equals equals in this case because I only have two players. They're always going to be in the same memory location. It'll never change. So equals equals in this particular case is what I actually want. So there's this, you should not go to your way to optimize your code and think too much about speed. But there are a few things that come up. So most of the time, we're going to have the player set, right? So we can just say else. So this is for the no player set. Sorry if you can hear my cat screaming downstairs. We're all busy and the doors are all closed. He doesn't like that. So we're much more likely to have the current player have a value than it be null. The null only happens once. And we could even optimize. So the optimization is we don't have to check for null first because checking null first would happen all the time and it's only ever null once. So why check for it all the time? But we could even get rid of this check if we wanted to. By doing this, we could say current player is assigned player 2, right? And then the current player wouldn't equal player 1, it would equal player 2, and we'd set it to player 1. It's a trick though, right? So what we're saying is we're going to start the game with a player who isn't going to take their turn. Right? So it's in Monopoly, it would be the person who was going last would be set temporarily as the first player. That's tricky. It's not obvious. Therefore, I want to make a comment in here saying, what it is, why I'm doing this weird thing. And I don't like to do weird things if I can avoid it, believe it or not. So I'm going to stick with my else. Now, the problem is we don't have player 1, player 2. We can't access them. So, what I'm going to say is there's various ways I could go about doing this, and I'm going to take the cheap way out right now, and we'll come and see some design decisions later on. But the simplest thing to do right now is go to the game class and make these protected, especially if you can spell it or type it. So by making it protected, that means that subclasses can access it. So game has a subclass of board game, and board game has a subclass of tic-tac-toe game, and lo and behold, there we go, it works now. So we're good. So we can get our next player, and is over. Let's just for now it's a really bad idea to do what I'm doing right now, which is making a random variable that's going to get called every single time. We should really move the random variable out, but I don't need it for this is throwaway. So right now we're going to have a random a game that just plays randomly for the whole time, and we can take this whole thing and we're going to return the next player. And now we also need to say that the current player is assigned the next player. So we come in and current player is set to null. So we go, it calls get next player. We check to see is it equal to player 1? Nope, because it's null. Player 2? Nope, because it's null. So we set next player to player 1. We set the current player up here to player 1, and we return next player or current player, your choice. Again, depending on how your VM is implemented, this is going to be less efficient than this. They return the same value. This one, is possibly faster. It's this very small thing. I wouldn't worry about it too much, but it's a thing you could be aware of if you used to be. So that goes to the game. So the game wasn't over, or it was randomly not over in our case. We got the next player, so now that's got player 1. Player 1 takes their turn. And then, Player 1 takes their turn, and we check to see if the game's over, and then we get the next player. So we come back to tic-tac-toe game, and we get the next player. So current player was set to player 1. So does it equal player 1? Yes, it does. So we set the next player to player 2, set the current player now to player 2, and return player 2, and it goes back and the game plays its with the next player. So I paused there for a second because I'm not 100% sure this code is going to compile yet. Let's see. It does not, and okay, checkers game hasn't been coded yet, so let's quickly code checkers game. That's what I was going to do before I noticed that I don't think something works, but that's okay. Okay, checkers, make sure I got the right thing. Let's just grab the whole. Oh, let's grab all of it. So that's checkers player. This becomes a new checkers player. This becomes a new checkers player. This becomes. Oop, did I do that? I did that wrong. This should be player A. This should be player B. And this should be new checkers player. And now I need to also make sure I go back to my tic-tac-toe game and fix the same thing. Everybody makes mistakes. This is where unit testing comes in handy, because if I had unit testing, I would have passed in O and X, and it would have always returned X and O, and I would have been very confused, and it would have caught it. So there's a good reason for unit testing. And this should be red and black, or black and red, I don't really know, or care, the particular order they're supposed to go in. So now we're not dealing with, we're dealing with a checkers player, and this is a checkers game. Because this is a checkers game, and that's a checkers game. And we need to change this all to that. Now, what did we just notice though? There is zero difference between this and this for the get player. Totally the same. When I have two methods that are totally the same in a child class, I'm going to take it and I'm going to move it up to my parent class, because why not? So this becomes P instead of tic-tac-toe player, because we don't want to tie it to that particular one. This becomes P, right? Could be a checkers or a chess or a tic-tac-toe. Go back to tic-tac-toe game. The current player. Grab that. Right, so this code here, because of the generics, works for both tic-tac-toe and chess or checkers or whatever other, Monopoly, any other board game player we have. As long as the way we want to do it is to just go from player 1 to player 2. Again, we'll make this code better later on when we allow for more players. But for now, we just, this will do. And if we're going to say all our games have 2 players, and then we have a game that has more than 2 players, we can override the get next player method for just that game. So this gives us the ability to have 90% of the code or subclasses use this code, and if they don't like it, they can override it and do it themselves. That also means we can rip this out of the checkers player. Right? I do not want to have 2 methods that are the same. Now, the moment the is over is stupidly written and is the same for both, but that's fine. But notice that my code just magically got smaller. I like it when my code magically gets smaller. So let's go to the tic-tac-toe player. So I don't need to think. So it extends player. And what is wrong with it? Doesn't have the take turn method. So there's no board game player or anything like that. So take turn player, public turn. This is what I was thinking wasn't going to work before. Wait, I don't think I've implemented take turn anywhere. For now, I'm just going to return null. I should again throw the illegal. I'll just put it in as a comment. Should really be throwing this instead. But again, I don't care about this at this moment. Sure, checker player, takes a turn, returns null, don't care. So let's go to our game just for a second. And now we're going to system.println the current player dot get name. So it should just cycle through for a random number of times between X and O or whatever. Unfortunately, we have not written a main method yet, so we've got it here. So here we're going to make a tic-tac-toe game. That's it. This is what we've been trying. This is what we strive for, right? I have a very simple to understand system. I have a game. I'm going to play it. Okay, well, what does play do? Well, now I have to go to the game. Well, so I made a tic-tac-toe game. So let's go there. And there's no play method in here. So we go to board game. And there's no play method in here. So we go to game. And there's a play method here. Cool. So, well, the game is not over. Go back to tic-tac-toe game. Is there an is over? There is an is over method. We're going to call it. It's going to randomly return true or false. Okay. And then, so we go back to game. So let's say it didn't return that it was over. So we're going to get the next player. So we're going to go to tic-tac-toe game. Is there get next player? No. So we're going to go to board game. Is there get next player? There is. Is a player set? No, it's not. So we're going to set it to be the first player that was passed in, right? And then back to game. We're going to ask the current player to take their turn. So go to the tic-tac-toe player. They're going to take their turn. It's going to return null. Fine, whatever. So that would put the piece on the square, though, in reality. Again, we'll worry about take turn later. So back to game. Is it over? Go through the same process, right? So this is where students start to get really confused, I think, because you have to keep jumping through all the code. This is where drawing those diagrams to show which classes have what methods and all that is important. Now, in reality, when you design the system and it's not very big and all that, you can very quickly navigate through it. But like I've shown you, if I don't know what would happen if I say go to here, because this is overridden, it'll just go to the appropriate thing. So I do need to start keeping a mental model in my head. But honestly, once you've done this for a while, it becomes pretty simple. But those diagrams, at least to begin with, if not longer, really do help. So let's try playing the game. See if it blows up. Didn't blow up. It also returned false. So let's try again. There. An X and an O. An X and O, an X and O, an X and O. And it returned false right away. Right? So remember, it's going to be random because we're doing random things, but it seems to be having X and O take turns. Right? So here's what's really nice as well. We can take this, we can go to our checkers game, we can go to the main method there, we can change this to checkers game. Make this a checkers game. And voila. So things that look the same probably behave the same, right? So checkers game, right? We can play it. It's going to do whatever the appropriate play thing is, right? If we made Monopoly, right? Monopoly is going to play very differently. There's going to be dice rolling and all that kind of stuff. But the concept is exactly the same. Do you want to play a Monopoly game? Yeah, let's play a Monopoly game. Okay, play, right? It's meant to mimic real life, and that's exactly what it does.